So today was our second day completing the square of quadratics. The ultimate idea of completing the square is to go from standard form of our quadratics and convert it into vertex form. Why this is a useful technique is standard form is a little bit harder to graph than vertex form, so maybe you want a format that's a little bit more straightforward for graphing purposes. Vertex form, in essence, can be a lot easier to solve because you boil down these two terms with x's to just a single x term. So we can solve this like an equation, where standard form, if we were to set this equal to a number like 0, we would have to see if it was factorable. If we set it equal to 10, you see if it's factorable. While vertex form, regardless of what you set it equal to, 0 to 10 to 100 to 90, I'm only adding those just because it kind of works with the numbers, you solve it the exact same way to get x. Well, this one, every single number changes the entirety of the equation. You factor it completely differently depending on these numbers right here. So vertex form can be a lot easier to solve, given that vertex form might be an easier equation. So take this vertex form, or this standard form equation, f of x equals x squared plus 8x minus 6. If we were to solve this one and say f of x equaled 0, we would have to factor this or see if it was factorable, graph it, use the quadratic formula, and then go for it. If we wanted to then use the same equation but solve for 10, we'd have to start all the way over and factor again, and we'd have to graph again. We would have to use the quadratic formula again. But by having it in vertex form is a lot more straightforward to solve for multiple different answers. So the first thing we're going to check is to make sure that our a value right here is 1, which it is. Since it's 1, we then look at our middle term b, and we're going to take half of it. So half of b is 4. We're going to square it and get 16. By doing that and adding that 16 to our equation right here, plus 16, we actually create a trinomial that's factorable. Right there, we have a factorable trinomial. We could use the AC method, we could use any of the methods we know, but that's factorable. But we don't want to change the overall part of the equation, so we're also going to subtract a 16 to counteract the 16 we just added, and then we still have that minus 6 on the end. This trinomial factors into a perfect square trinomial of x plus 4 quantity squared. Off to the side, we'll kind of look at the long way to factor it. The AC method tells us 1 times 16, so 16. Two numbers that multiply to 16 that add to 8, 4 and 4. So x squared plus 4x plus 4x plus 16. We get x plus 4. Take out another plus 4, so we get x plus 4. And there's our identical binomials, x plus 4 times x plus 4. We don't want to have to do this on every single problem because it's repeatable. This is a pattern that can be repeated very quickly, very straightforward, and very predictably. This trinomial will always boil down to this, and it will always include the number that you've put off to the side up here. Positive 4, positive 4. By doing that, combining our like terms, here is your vertex form equation of our quadratic. Then from here, we could use it to solve any sort of question we would need. So let's try another one like that. But on this problem, we do have a leading coefficient. So before we can do anything, I have to get rid of this 3. The simplest way to do this is to factor a 3 from everybody. So I'm going to divide everybody by 3, and I'm going to store that 3 on the outside. So 3 divided by 3 is 1. Negative 18 divided by 3 is negative 6. And negative 21 is negative 7. That 3 is going to stay on the outside of our problem the entire time. Not going to worry about them. Now that we have a 1, we're going to complete the square. Half of b is negative 3. We square it and get 9. So our function now says 3 x squared minus 6x plus 9. Subtract the 9, subtract the 7, end parentheses. So we have now created our trinomial we're going to factor right there. Let's go with green. So we still have the 3. Like this. I'm going to combine my like terms to negative 16. And I get x minus 3. Whatever number we put up here goes right there. The last simplifying step that we're going to do is we're going to redistribute that 3 to everybody in the parentheses. So the 3 multiplies there. 3 x minus 3 quantity squared, and 3 times negative 16 is negative 48. Everybody gets multiplied right there. And we're done. One more for good measure. What happens if we have to take a 3 from everybody, but we can't take 3 evenly from one of the numbers? So there's 14 over here. Luckily, we take out a 3 at the beginning. That's 14 divided by 3. And if we go back to this problem, eventually we're going to bring that 3 back in, so we won't have to deal with this fraction for very long. I'm going to complete the square, so I need to take half of my middle term, which is 8. I need to square it, 64. And our function becomes 3 x squared plus 16x plus 64 minus 64 plus 14 thirds. Again, here's that trinomial we're going to try to factor here in a second. There's our perfect square trinomial. It is x plus 8 quantity squared. But I'm not going to combine my like terms just yet. I don't have to combine just yet. What I'm going to do is I'm going to strategically multiply back in this 3. By multiplying in the 3 here, I won't have to create my common denominators. 3 times 64 is 192. But then this 3 multiplies the 14 thirds and actually gets rid of it back to just 14. So I kind of just stored the 3 on the outside for safekeeping. I combine my like terms. I get negative 178 for our vertex form. So let's try a few that would be on the back side of our homework, actually solving them. So notice the very subtle difference between this problem and one right before it. I'm asking you to solve for a very specific answer. When does my quadratic equal 0? On this one, I didn't tell you when it equaled anything. I was just like, this is just the function. I have the quadratic blank. This is the same quadratic in vertex form. Quadratic in standard form, quadratic in vertex form. This one, I want to know the answer when it's 0. We could graph it if we wanted to. We graph our quadratic, there it is. I don't know, I'm just rough sketching it. I would want to know when it equals 0 right there. It might be factorable, it might not. Let's assume that it's not, and let's assume we don't want to graph it. So we're going to convert it to vertex form. So we already have 1 for our a, don't have any leading coefficient. We're going to take half of b, and we're going to square it. X squared minus 20x plus 100 minus 100 minus 182 equals 0. I can factor my trinomial. Combine those, I get negative 282 equals 0. And from here, we're going to solve for x. So I'm going to add 282 to both sides. X minus 10 quantity squared equals 282. Square root x minus 10 equals positive or negative square root of 282. And then we add 10. So the answer starts off as 10 plus or minus the square root of 282. Before we end our problem, we are going to simplify any non-perfect roots. So I'm going to check on my calculator here what perfect squares go into 282. So I'm going to check 4, I'm going to check 9, check 16, check 25, 36, yada 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 until I find one. So 282, I'm going to start with 4. 4 didn't work. 282 divided by 9 didn't work. 282 divided by 16 didn't work. 282 divided by 25. 282 divided by 36. 282 divided by 49. 282 divided by 64. 282 divided by 81. 282 divided by 100. Of course not. 282 divided by 121. 282 divided by 144. 282 divided by 169. 282 divided by 196. 282 divided by 225. All of my perfect squares through the list, none of them have worked. So this one cannot be simplified. So we get to keep our answer right here. Next one. We have a number in front of our x squared. So the first thing we're going to do is we're going to factor that 8 out. So there's what our equation looks like. Now let's complete the square. Half of our middle term is 1. 1 squared is 1. So we still have that 8, just chilling. X squared plus 2x plus 1 minus 1 minus 4 equals 0. I can factor my trinomial now. It's a perfect square trinomial. I get 8 still in front, x plus 1 squared minus 5. Going to redistribute in the 8. And now I'm going to solve. Add 40 to both sides. Divide by 8. Square root. X plus 1 equals plus or minus root 5. The final step, subtract 1 from both sides. It is very important that it's a negative 1 plus or minus the square root of 5. You don't write the 1 with the plus minus. The square root has the plus minus. Once again, we check to see if we can simplify this. So does 4 go into 5? No, and no need to check any of the rest of them because they're larger than 5. That is your simplified answer. Just for good measure, let's say we have the square root of 96. It's in our problem. The answer has gotten down to, let's say it's like 12 plus or minus the square root of 96. That's your answer. You've solved it, and you're like, yay! And you're like, I got to simplify this thing right here. Well, you're going to check 4, 9, 16, 25, 36, yada, 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 all these perfect squares until you find at least one of them. So again, grabbing my calculator, 96 divided by 4. Bam! I found one. Don't waste any time trying to find the largest one. It can save you some time, but just find one of them. What happens is we split this 96 into 4 and 24. That's a perfect square. We're going to do the same thing for 24. Hey, look, 4 and 6. So here's my perfect squares. By splitting this, we've basically created this. 4 times 4 times 6. And I'm going to square root these because they're perfect. So 12 plus or minus 2 times the square root of 6, which means this becomes the square root, or 12 plus or minus 4 square root 6 for our final answer. So that's what our simplified answers should end up looking like on our problems.